I guess we are live. So, hello everyone. My name is Tarun. I'm a community manager at AI Planet, and I welcome you for this live session on learn how to self-host your Stable Diffusion API. Today we have Thomas, who is a machine learning developer evangelist at WordCap and also a Hugging Face fellow. He will be briefing out about Stable Diffusion and how you can host your Stable Diffusion API, and he has also created a project called Pick EISO, which is an open source implementation of Stable Diffusion and also a Discord bot. So, without a further ado, uh, hi Anna, I welcome Thomas to start the session. So, thank you.
Hi Tarun, hi everyone. Thanks for the invitation. So let's start. We just share my screen. So yeah, as Tarun said, I'm doing machine learning for some years right now, and recently I built a self-hosted Stable Diffusion API, and I will talk about it today. So just a quick introduction for me. So I'm Thomas. I was a former teacher in France, and then I decided to retrain in deep learning 2 years ago. After that, I had the chance to join the Hugging Face Fellowship crew, which is like a program from Hugging Face to support me in my open source journey. So that's pretty cool. And yeah, today I'm working at WordCab. We are an NLP startup, and our goal is focus on summarization, and also we bring fine-tuned large language models to companies like call centers, to help them in their workloads, workflow, and to improve client insights. All the all the pictures were generated with the project I will show you today. Maybe not this one for WordCab. It's a logo for one new product which I'm building. So yeah. So before diving into the code, I would like to talk about a bit about diffusion models. So the presentation is not about. I mean, we won't talk only about diffusion models, but it's great to know what diffusion models are. So we used to have GANs, so generative models, to create images from white noise. And recently, maybe 2 years ago, one paper came out about diffusion models, and yeah, it became really something huge with the recent latent diffusion models paper. So I put some links here. It's just about so you can find links maybe in the presentation, but this paper introduced latent diffusion models, and which are the models we are using right now. They are really great and generate some really interesting images from white noise. So I also linked a Lilian Wang blog post, which is about the diffusion principles. So if you want to learn more about what are really diffusion models with a lot of mathematical details and also historical details, then you should read this blog post. They are always great from Lilian. Yeah, so you just need to keep in mind that diffusion models and specifically latent diffusion models are generating images from white noise. And with latent diffusion models, we can like give them just a few words or a full sentence, and they will generate an image based on that sentence. So papers are great, but it's even better when things are implemented and usable by people. So StableDiffusion is a model which was created by researchers and engineers from multiple companies like Stability AI, Compleans, Runway, and Lion. Lion maybe for the datasets. And they open source a lot of checkpoints, which are available on the Hugging Face hub. So the great thing is you can choose one model for your use case, depending on what you are looking for. If you want to produce different kind of images, and also you have different resolutions. So like StableDiffusion version 2, you can have 2 different resolutions. And after that, there are also another model that could upgrade the size of the images. So you have a lot of choice to use. And diffusers is the library from Hugging Face. It's great to have that kind of library because diffusion models are a patchwork between different kind of model. So you have one UNet, you have also one variational autoencoder. You can have a model to filter out nudity pictures or stuff like that. And so diffusers helps you to build a stable diffusion pipeline by just with one line. You can create a pipeline and use it, and you don't have to deal with all the different models. They are available on Hugging Face, and it's almost automatic. Yeah, so after this little introduction, let's see what's the code source, what I built, and what you can do with stable diffusion and stable and diffusers. So I just need to open the code repo, so you will be able to find all the code on GitHub. It's free, so you can check it later. Obviously, I just need to share my screen and change the window I'm sharing. Okay. Okay, so we are on GitHub, and we will just see how it looks. Maybe before diving into the code, I must show you the how it works. Like, what's the final product I built? Could be better. I'm just sharing Discord because this is how you interact with the API and the bot. Yeah. So the final product is here, Peak AI So. It's just a Discord bot, and I can simply write something like generate maybe a mountain, let's say a beautiful mountain, 8K, realistic, dream colors. Let's see. So I prompt him with some words or a full sentence, and then the model generates an images, and the bot take the images and give it back to me. And I can just keep sending prompts to the bot, and the bot will request to the API and come back to me with a picture. So I get inspired by Midjourney. Midjourney is exactly that, just a bot on Discord where you can get some generative art. And I wanted to know if is it difficult for someone to do exactly the same thing and self-host it on his personal computer, because at the moment the API and the model is hosted on my personal computer, um, and it's working and doesn't necessarily need too much compute or resources. Obviously, if a lot of people are requesting the bot and using the API, then the wait time is increased. But for now, it was more a project for me and my friends on Discord. So for now, it's largely enough. So, okay, let's go dive into the code. So there are two different parts. There is the API, which is like an extra layer on top of the StableDiffusion pipeline. So the API is interacting with the model to generate images. And we have the Discord bot. The bot is just the way I chose to interact with the API. So you can build anything like a Slack bot or even a web application. The only, I mean, the only thing why it's a Discord bot it's I wanted to replicate what Midjourney do. Um, they have a Discord bot and you can just prompt it. So I thought it was the best way to generate art and to interact with the API. But in fact, you can build anything on top of the API. So this is the GitHub repository. I wrote a README about how you can use my own self-hosted bot. So you can invite Peak AI So, the bot, on your Discord server, or you can self-host yourself the API or the Discord bot. So this way you are free to use the project as you want. There are some requirements, obviously. Everything is running on Docker. You need, if you want to self-host the API, you need at least one GPU with at least 12 gigabytes of VRAM. The model is taking between 9 and 10 gigabytes, but to generate one or two images, you need at least 12 gigabytes. So, and you have all the explanation on how to set up things. I think it's not really interesting to see the instruction right now, but maybe to see what's inside the code. So the first thing, you have a config folder, which is separated into API and bot. It's simply environment template file. You will have to update them in order to define your own environment variables. So it's simple, like it's just the project name, the version description, the API prefix for the API, and also all the authentication part. So you have to define one username, password, one open SSL key, and also you have some configuration for the model. So you can change the batch size. The larger the GPU is, the larger the batch size can be increased. So right now I'm running on one RTX 3090, so batch size 4 is enough. It means that the API can take 4 different requests from users and respond with 4 different images. So it can the maximum I can generate is 4 images in one batch. If your GPU is smaller, consider using a batch size of 1. So this way you avoid CUDA out of memory. Yeah, the max weight is another parameter because I coded the batch request. It means that multiple users can request an images, and there is a queue where people have to wait in order to get a response, an image as a response. So the max wait is half a second. So it means that even if the queue is not full, so even if we don't have 4 requests, then the API decide to run a batch, even if it's not full. And yeah, you have some configuration for storing images if you want to store them. Anyways, let's see more in detail. Docker, I will pass on this. It's just we can see that later. So let's see what is inside the API. So we have the config file. Config file is just loading the environment variables and just using them in the API. Dependencies. Yeah, I didn't say that, but the API is built with Fast API, and I wanted to allow people to expose the API to the internet without any problems. So you can define some authentication, username and password. So this way people can't access your API without credentials. So dependencies is all about that. It's just it's just the code behind authentication. So it's not really interesting, but it's a bit. I mean, it's a bit complicated, but it's like the API include an access token via Beaver and stuff like that. So it's really safe to deploy the API because without credentials, no one can use it. So if you don't want to share the credentials, and you should not share the credentials, then it's great. Diffusion model, it's where we define the diffusion pipeline things. So as you can see, we just import diffuser, and from diffusers we use StableDiffusion pipeline. It's a class I define just like an extra layer. So by default, precision is torch float 16, which means that the model takes less VRAM on your GPU, and most of the time it's largely enough to produce great result. Here it's just loading all the different settings for the model. These are the multi requests I talked about before. Like you absolutely need multi request support if you want to be able to have multiple users, and that's the case for Midjourney because they have tons of users. So I was really interested in implementing batch request and multi request. So these are the basic setup. So the model is loaded. It's a StableDiffusion one. It's not the original StableDiffusion I'm using right now. It's a fine tuning from Prompt Hero. The model is named OpenJourney, and OpenJourney tries to replicate the Midjourney model. So It's not the original one, but almost the same. Maybe a bit better on some quality prompts, but yeah. We use the recent Tom SD, which is Tom Stable Diffusion patch. It helps the model to go faster than ever. So that's great. This next function is just a function that looks if there is some thing to process in the queue. So when a user make a request to the API add the request to the queue, and then if there is something to process, the API, waits for the max wait, and even if the queue is not full, it processes the batch of requests. So the next two functions, process input and runner, is everything you need for batch request and multi-request support. So an event is going through the API, it just enters the loop into the queue, and I store the prompt from the user, and the task, like one request is like a task, is added to the queue. And when the task has been completed, I return the result. The result is just the image the user requested. The runner function is where we use the model to produce results. So this is where we define the queue, and this is where the runner is always running in the background and waiting for new tasks. So runner is launch at the beginning of the startup when you start the API, and is always looking if there are tasks in the queue. If there are tasks in the queue, then it takes a batch. So in my case, it takes 4 tasks, and then for each task, it generates a list of prompts, and after that, the runner is using the inference function to take the list of prompts and give it to the pipeline. So the pipeline is just running the model on the GPU and then return results. When the results are here, we just need to zip the result to the initial prompt. So this way, if I ask for a cat, for example, then I get the cat image back, and I won't get any other images. It's to avoid mixing 2 prompts and getting a result you don't want to. Sorry. So it's just the diffusion model, and so all the batch request logic is here. And in the main.py file, you have the API logic. So if you are familiar with FastAPI, the only different thing we are doing here is just we create the diffusion service, which is the model behind the API, with the settings we define inside the environment file. We have a startup event. So at the beginning, we run the diffusion service runner, and the task is just run in the background. So that's it. The model is ready, and is just waiting for tasks. Okay. We have a main health check endpoint, but we don't care about that. It's just when you go on the API, it's the first thing you see. And so we have one authentication endpoint just to authenticate using the username and the password I mentioned before. And the API will send you back if credentials are great. The API will send you back a token, a bearer API token. And yeah, we have the generate endpoint, which is the one which is interesting us. So the API expects you to send a data model, which is just a prompt. So it's just a string. We define background task. It's just for if you use S3 bucket to store generated images, you need a background task. Otherwise, you don't need it. And current user, it's for authentication purposes. So it means that this generate endpoint is available only if you are authenticated with the API. If you remember well, I said the API is safe to use, so you have to include these dependencies to this endpoint to make it accessible for user only if they are authenticated with the API. So here we are just adding the prompt to the queue for the model, and when the task has been completed, we get an image as output, and then we just need to convert the image from NumPy to PIL and return the PIL image to the user. So if you are using the API, you will receive a JPEG image, and if you are using like the bot will resave the JPEG, and after that he can show the image on the Discord channel. Others files are not really interesting. This is just the input and output models for the API. So nothing too complicated. And yeah, this is just an util function to send generated images to one S3 bucket if you want to store generated images. So this is the API part. I believe we can access the API documentation. Just let me find the right URL. So right now I need to change my screen. Yeah. So this is the landing page when you open the API, when everything is running. It's the health check endpoint I mentioned before. So nothing too complicated. Just I needed a landing page, and you can just click on the docs endpoint button, sorry, to access the endpoint. So the code I show you is here. I mean, we have the authentication endpoint, the generate endpoint, and the status, which is the health check. And as you can see, the generate endpoint API v1 generate is locked by this little locker, and it means that if I'm not authenticated with the API, then I can't use. So let's try it out. So if I do the same prompt, mountain view, 8K, dream colors, realistic, ID detail, and I do execute, then I get an error, unauthorized, because I'm not authenticated. So if you have the if you have the URL, you can't even use it if you are not authenticated. So I just need to authenticate. So by clicking on authorize, I can add my personal authentication thing. I click on authorize, and so right now I'm authenticated. So let's do it again. Oh, you don't need to pay attention to author. It's because I set it up this because when you store things on S3 bucket, I can separate things by author from Discord. And that's it. Now I'm authenticated, so the prompt is working, and I get the response here just on the API. I can just keep requesting something. I will get an image, yeah, another one. And yeah, that's it. The authentication endpoint is for users when you want to authenticate, the Discord bot is using the authentication endpoint to authenticate with the API. So I think that's it for the API. The hardest part was to connect the model with Fast API and enable batch requests, so to handle multiple requests. We can take a look. Oh yeah, I need to change my screen again. We can take a look at the Discord bot, which is really simple, nothing too complicated here. It's just a main.py file. I don't know if you are familiar with Discord bot, but Discord bot are just asynchronous application. So they are always waiting for messages or stuff like that. This one is named OpenJourney bot, just because the model I use is OpenJourney. But I could name it Peak AI So. Anyways, the first thing doesn't really interest us. So the interesting thing is the authenticate function, which is asynchronous too, because you have to define asynchronous functions to let the bot works. Like, because the bot is on Discord, it means that multiple users can play with the bot and ask the bot to generate heart. So the bot needs to be asynchronous and use asynchronous functions from Python, because if you don't do that, it means that if one user is using the bot, then it blocks everything from other users, and you don't want that. You want multiple users be able to communicate with the bot, interacting with it, and that's it. So that's why we are using asynchronous here. So we are just authenticating us with the API. So we are using username and password, and we get a Beware API token back from the API. And once the bot is authenticated, is available for generating art. So this is the command from the bot. So when you create a Discord bot, you have to add commands to the bot to let users interact with it. So the command is short. It's checking if the prompt is not empty. It's important because it's always generating weird stuff if the prompt is empty. So if the prompt is not empty, then he answers directly to the user, saying, okay, Shenyo, you requested this prompt. And once he sent a message, he creates a new task, which is generate art, and it's using the user interaction and the prompt. And the function generate art is where we do one API call. So we post using the API URL /generate. So we use the generate endpoint from the API, and we include data. So we include prompt and the Discord name from the user. Again, author is not really important. It's just for storing purposes. So if the API answer a 200 as a response status, then it means the API, the API call is a success. So we can read the response to get the image, and then just using Discord file to embed the image inside Discord. Here the bot will edit the original response with a new message, like sorry, like here is your heart, Shenyo, and yeah, with the prompt and one attachment, which is the image. If the status is 401, it means that the bot is not authenticated anymore. So it must authenticate and then regenerate art again. And if we get a problem with the API, then there must be one internal server error. So we give we raise one exceptions, and also if there is one error with the API or anything during the generating art, then we just warn the user that something went wrong. So this way the user doesn't wait for nothing. And yeah, so the bot is created on Discord. It's explained on the GitHub repository how you can create a Discord application. So we won't go there right now, but when the application is created, you get a Discord token. So this way you can run the bot through Docker and just use this Discord token to authenticate yourself with Discord developer portal. And yeah, I think we have done we have seen everything here. So I can reshare again the final result with you. Yeah, which is on Discord. So you can invite the bot to your server, the one I'm hosting right now. Or you can self-host your bot and invite it to your server following the instructions on GitHub. And yeah, I want to show you what is batch request. So right now it's just me, but imagine that we are maybe 10 different users doing requests, like doing a lot of requests. So the only thing is my connection is not, Discord needs to deal with a lot of message, but as you can see, there are 4 messages taken by the bot, and we don't have the answer right now, but we get it by batch of answers. So I requested maybe 10 different images, and nothing crashed. Like all my requests are stored in a queue, and then that's just working. I think that's the most important thing when you have a lot of users. is like making a queue and just storing requests from user and avoid queue out of memory, because if you are already doing one inference and another request come, then it's the crash on the GPU. So yeah, I think the batch request is the most important thing. Okay, so I'll come back to the PowerPoint. So we saw the end on time. So yeah, if you want to self-host your StableDiffusion API, just go to GitHub, Shenio pick AI so, and you'll find everything you need to start. So thank you for listening, and thank you AI Planet for the invitation. If you have any questions.
So thank you so much, Thomas. It was really very great session, and we have few questions in this chat. Uh, so the first one is, what's the minimum system requirements for self-hosting it?
Yeah, the minimal requirements is like a post computer having one GPU with at least 12 gigabytes of VRAM. To be honest, I will recommend 16 gigabytes, just to be sure that you can generate great results, because images are taking a lot of space on GPUs. But yeah, between 12 and 16 gigabytes for one GPU is enough to run the API.
The next question is, how to optimize the latency or inference time of the API with the minimum server requirements. Any best practice that you follow will be helpful.
Yeah, I was quick on that, but as you can see inside the initialization of the model, I'm using Tom StableDiffusion, which is something new, which came out recently and is doing some optimization on the image without reducing the quality so much. So just by using this library and maybe adjusting the ratio, you can multiply by 2 or 3 the inference time with your Stable Diffusion pipeline, which is really great. And if you want minimal server request, then just host the API on somewhere with a great internet connection, obviously, but where it's accessible. Like if you have users in Europe, then just host the API in Europe. If your clients are in the United States, then host it in the United States. So you have to be careful with that. For this project is more for fun, actually. So I'm not really looking at that, but yeah, some latency problems can be solved with the code, and sometimes you have to deal with the server you are using.
The next question is, how is Pick AI so different from its journey?
I think the real difference is like everything is open sourced with Big AI, so, and we are using one open source model, which is Prompt Hero. And Prompt Hero is based on Stable Diffusion. But Prompt Hero Open Journey model is trying to replicate Midjourney quality, but to be honest, at the moment, it's totally impossible to replicate Midjourney quality, especially the version 4 and version 5 models. They are too great, but yeah, you have to pay to use them. So the difference is that you don't have to pay to use PKISO, and you can self-host it on your personal computer if you want to generate some art, and you can tweak the parameters to adjust for anything you want. So I think it's the main differences. Yeah, it's free.
Yeah, okay. There was a similar question, but I hope you have already answered that question. Like, is PKIS or Discord bot free? So I guess that question is answered.
Yeah,
And he
and
had a
if
similar question.
us, yeah.
Okay. So are there any ethical consideration you keep in mind when developing or deploying AI models, and how do you address them in your work?
Yeah, I think this question can't be answered in like 5 minutes, to be honest. But yeah, obviously, ethical considerations are just impossible to pass on. I mean, you have to keep that in mind every time you develop something. For this particular Stable Diffusion implementation, there are a filter, a nudity filter, and maybe filter also for I don't know, criminal thing. Or so when one user is requesting something that is not really, I would say, not safe for work, like sexual content or aggression or too much blood, then the pipeline is outputting only a black screen. So users can't request things too too problematic from PKISO, and it's automatically implemented inside the Stable Diffusion pipeline on a game face, which is great. You can always disable it, but for this project, I have kept the filter. So sometimes you are requesting um, something normal, which is not disturbing or anything, and you get a black screen, then yeah, sometimes it doesn't really work, but all of the time it's a great tool to filter out problematic images.
Yeah, okay. And the next question is, what actually does diffusion service does in fast API? I mean the code block, I guess.
Um, when you start up the API, diffusion service is handling for you all the model loading, uh, configuration, and all the runner loop. So it means that once the API is launched, you don't have to reload every time the pipeline, every time one user is requesting for one image. So it's like you load the model once, and that's it. It's loaded and ready to be used.
I guess we are done with question and answers, but let's wait for 2 more minutes if you have any other questions. If you have more questions, comment it down.
Um, Maybe we don't really answer the PKI, so Discord bot free. I mean, yes, it's free, but the both versions are free. Like if you want to self-host it yourself. Um, it's free because you can just use the project everywhere you want. Obviously, if you have to rent one GPU, you will have to pay the renting for the GPU, but the application itself is free. And if you want to use my self-hosted version, it's also free. So you can just invite the bot on your Discord server and you will be able to use it. Maybe a little disclaimer, the bot might be offline sometimes. Like it's not like Midjourney where you have the bot every time up. It's depending if I need to use my personal GPU or not, or if I'm not paying a cloud service for renting one GPU. So yeah, it's totally free. And if you face any problems using the model, using the API or the Discord bot, just open one issue on GitHub or contact me on LinkedIn or Discord, and I will be able to help you.
Yeah, okay. So I'll be sharing the link of the GitHub in the comment section so that anyone can. Okay, so I've shared the GitHub repository of PKISO, and I have one last question from my side. What are the common challenges one might face in hosting stable diffusion model in real time?
Um, yeah, having one GPU available for the project is almost the main the main important thing to have. Like if you don't have one GPU, I think these kinds of models doesn't really run on CPU. So it can be complicated because the minimal GPU you have to use, as I said before, is one GPU with at least 12 to 16 gigabytes of VRAM. So I'm not sure. I'm not a user from Google Colab, but I'm not sure if you can run it on Google Colab. But maybe some GPUs. I mean, on the free version of Google Colab. Obviously, on the Pro version you can run it, but on the free version, I'm not sure if the GPUs are enough to run it. Maybe if you have 16 gigabytes, it's enough. Um, but yeah, Google Colab is a bit clunky if you want to expose the API. So you have to use a personal GPU or a cloud-based GPU, like on Google, AWS, or Azure. Or I'm using also Fast AI, where I can just rent for 1, 2, or 3 hours some GPUs, and it's not so expensive. So it could be a cool alternative to usual cloud providers. And the second problems for uh, that kind of models is finding the right parameters between great image quality and fast inference. Like if you want like great quality, sometimes you have to change the number of steps the model is doing the inference, and if you put I don't know the number of steps like 1 or 200, it can take several seconds, which become too long for users. Like most of users want their images rapidly and as soon as possible. So you have to deal with parameters and good image quality. Um, I think you're on mute, Tarun.
I'm sorry. Okay, so we have one last
No problem.
question. Does running
Yeah.
NVIDIA in SLI will help the stable diffusion, or will the results be the same?
Um, by NVIDIA SLI, you mean the thing to connect two different GPUs together? I'm not sure if it's that, but the more GPU you use, the more model you can host on the GPU, and also the batch size can be increased. By default, this project is designed to run on only one GPU. So if you are using multi GPUs, you will have to update the code a bit, especially the Stable Diffusion pipeline, to be sure that multiple models are run on multi GPUs. But yeah, obviously, if you use more GPU, then you can reduce the inference time because more compute resources are available for inference. So that's obviously better. But I think the image quality will stay exactly the same unless you change the parameters, like if you set up the number of steps, if you increase the number of steps. Yeah.
Okay, makes sense. So, do we have any more questions? I guess we have covered all the one. If any questions, do let us know. Okay, so I guess we'll wind up here. So thank you, Thomas, for sharing the expertise about the Stable Diffusion API and how to self-host it, and also for breaking through and going through the each line of Picasso, PKISO code. And we also thank our audience for participating and for the insightful questions. Your contributions have been enriching experience, and thank you for joining this session. I hope it was helpful. And we'll be sharing all these resources in our Discord channel, and we'll be sharing newsletters as well so that it will help you guys. And if you have any more questions, you can reach out to Thomas, and I hope he'll be, and I guess he'll be ready to help you at any time. And he can share your socials. We'll share his Twitter ID and LinkedIn so that you can reach out to him anytime. So thank you so much.
Thank you
Any
for
words
the
from your side?
invitations. Oh, sorry, there is a delay. Thank you for the invitation, and thank you for the AI Planet people who joined today, and for the questions, obviously. And I hope the project will help you to understand more batch requests and how you can self-host things easily or not, depending on your use case. Thanks a lot.